Well, we're on to lesson 4 of our trigonometry unit. This is trig identities. This is a a lesson that you need to work with. It's less logic and more of a puzzle. Some people get it right away, some don't. So it'll take some practice, but it'll be okay. So before we get started, I just want to remind that when we have a triangle on our Cartesian plane, we will be working with y, x, and r. And this is going to help us understand trig identities. So the identity is a mathematical statement that is true for all values of the given variables. So we're going to use the ratios from our triangle in the Cartesian plane to show that tan theta equals sine theta over cos theta for all values of x. Okay, this equal sign doesn't mean we can move things left and right. We have to solve the left side and solve the right side and make sure that they work, that they equal the same thing. That's what it means by true. So if we work with tan theta and we're looking at our triangle in the top right here, we know that tan is opposite over adjacent. Okay, so our left side, I'm working left side here of the equal sign. Opposite over adjacent, which is y over x. Okay, so that's all we can do there. But on the right side, we have sine theta over cos theta. And sine we know is opposite over hypotenuse, so we have y over r divided by cos, which is x over r. I'm just going to move this equal sign. Okay, so that says sine theta over cos theta. Now when we're dividing fractions, since we have two fractions now, we're going to leave the first one the same, and we're going to flip the second one and multiply. Okay, and if we multiply these out, we get yr over xr. And since we have common values on the numerator and denominator, we can cross out the r's, and we end up with y over x, which, as you can see, is the same as our left side. So this works. Okay, now we'll do the same thing with sine squared plus cos squared equaling 1. Okay, so I'm going to work, there's nothing to do on the right side, so I'm going to work with just the left side. So sine squared, we know that sine is y over r, and squared means multiplied twice, and cos is x over r. Okay, so we get y over r squared plus x over r squared. Okay, our denominators are the same, so we have y squared plus x squared over r squared. Okay, now to get to the next step, we're going to use Pythagorean theorem. Because x and y represent the legs in our triangle, and we know that r squared equals x squared plus y squared. So we're just inferred that x squared plus y squared is the same thing as r squared. So we can write r squared over r squared, and anything divided by itself is 1. Okay, so the left side, we worked it through, it equals 1. The right side was already 1, so this works. And what we're doing right now is just creating rules that we can use in trig identities. Okay, so this is left side equals right side. Okay, some other rules. So we have figured out that tan theta equals sine theta over cos theta. So that means, so therefore, cotan theta is the reciprocal. Okay, this is just a side note. Okay, and we've also figured out that sine squared plus cos squared equals 1. And what does that tell us? Well, if we wanted to isolate sine squared, so sine squared theta is 1 minus cos squared theta, which also means if we isolate cos squared theta, it's 1 minus sine squared theta. Okay, again, it's just moving one thing from one side of the equal sign to the other. We can do it for the law. We can't do it when we're proving. So anytime it says prove, you work left side, right side separately. Okay, knowing that, let's work left side here. So we have 1 plus cot squared. Okay, so we just wrote on the side that cotan is cos over sine. Okay, so we end up with 1 plus cos theta over sine theta squared. Okay, 1 is really a fraction of 1 over 1. So we have cos squared theta over sine squared theta. And remember, when you're adding fractions, you have to have common denominator. So we're going to change that first fraction from 1 over 1 to sine squared theta over sine squared theta, right? They mean the same thing. Now that our denominators are the same, we can get sine, we just add the numerators. And finally, we just found out from the last one that sine squared theta plus cos squared theta is actually 1. So we end up with 1 over sine squared theta. Okay, on the right side, so it's cosecant, and remember cosecant is the reciprocal of sine. So cosecant squared theta is the reciprocal of sine, so this is 1 over sine squared theta. And we just figured out that that's exactly what we're looking for. More often than not, there's not a whole lot to do on one side of the equal sign. So there was only one step there where there were 4 or 5 steps on the left side. So left side equals right side. Okay, identities that we can use to simplify more complex identities. They're what we wrote in the left-hand margin there that we used on this last one. But let's do them again. Tan theta is sine over cos. And sine squared theta plus cos squared theta equals 1. The idea with identities is that we want to change the way it looks so we can simplify it, but without changing the actual statement. Okay, so we're changing the way it looks, but not changing the actual math behind it. Helpful hints: change all ratios to sine or cos. Okay, so if it's in tan, if it's in cotan, secant, change it into sine and cos if you can. Be sure to follow all number and algebra rules, meaning BEDMAS, even quadratics we'll get into, and work with left side, then work with the right side. So we're doing it separately. Okay. So left side, it's tan x, which we know is sine x over cos x. So let's leave it there. We turned it into sine and cos, and then we'll work with the right side and see if we can get the same thing. Okay, so we have sine x plus sine squared x over cos x times 1 plus sine x. Okay, I talked about quadratics because on top we actually have, so we have two terms here, sine x and sine squared x. We actually have a common factor. So we're going to common factor out sine x, and we'll be left with 1 plus sine x, right? If we divide sine x by sine x, we get 1. Sine squared x by sine x, we get sine x. And let's leave the denominator alone for now, because now we see that we have similarities on our numerator and our denominator. So we can cross out this 1 plus sine x, and that leaves us with sine x over cos x, which is exactly what we're looking for. Okay, and I'll just make a note. For this step, we common factored. Okay, prove that sine x plus sine x cotan x is the same as cosecant. Okay, so left side. Okay, sine x plus sine x cotan squared x. Okay, we're going to change that cot x. Remember, we want to try to put everything into sine. So this is sine x, and we know that cot x is cos over sine. Okay, now we have a common factor. So both, we have two terms here. There's one here and this whole big one. We can take sine x out of both of it. So we get sine x, and we're left with 1 plus cos x over sine x. We know that 1 is really 1 over 1 when we're adding fractions. We're going to get sine x over sine x plus cos x over sine x. Okay, let's add those fractions. And we get sine x plus cos x over sine x. Oh, these are supposed to be squareds. My mistake. Sorry about that. It was cotan squared. Okay. Sine squared x plus cos squared x gives us 1 over sine squared x. And we can cross those out because sine x and one of the two sine x's inside are the same. So we end up with 1 over sine x. Okay, that one was big. The right side, we have cosecant of x, which we know is the reciprocal of sine x. Okay, so these are the same, and it works. Okay, so like I said, there's no real logic behind this. It's just working with the rules that we have. Luckily, in grade 11, we only work with a few rules. You need to remember quadratics, algebra, BEDMAS. Um, it takes practice, but you'll be fine.